Now let's study Ohm's law on the basis of his experimental observations. Ohm, a German scientist, discovered a law known as Ohm's law, which states that the current flowing through a conductor is directly proportional to the potential difference across its ends, provided the physical conditions of the conductor remains the same. Current proportional potential difference, or I proportional V, Ohm's law. So we can also write V proportional I, or V equal to Ri, where R is the constant of proportionality called the resistance of the given conductor. Now define resistance, the property of a substance or material due to which it opposes the flow of current through it is called its electrical resistance. For a given body, it is defined as the ratio of applied potential difference to the resulting current. Unit of resistance, the SI unit of electrical resistance is called ohm, denoted by symbol ohm. From Ohm's law, we have R equal to V upon I, which implies 1 ohm equal to 1 volt upon 1 ampere. Thus, the resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when the potential difference across its ends is 1 volt. Remember, R equal to V upon I defines resistance R for any conductor, whether it obeys Ohm's law or not, that is, ohmic as well as non-ohmic conductors, but only when R is constant. This relation R equal to V upon I is called Ohm's law. Now let's see the electrical resistivity or specific resistance of materials. The experiment shows that the resistance of two wires of different materials having the same length and the same diameter, that is, the same cross section, depends on the material of which the wire is made. The experiment also shows that if we take two wires of the same material and having the same diameter, their resistances will be different if they have different lengths. In fact, if the length is doubled, the resistance is also doubled, that is, resistance R is directly proportional to the length of the wire. R proportional L, equation 1. The experiment also finds that if we take two wires of the same material having the same length, their resistance will be different if they have different areas of cross section. In fact, if cross section area A is doubled, the resistance R becomes 1/2, that is, resistance is inversely proportional to the area of the cross section of the wire. are proportional 1 upon A. Equation 2. Combining 1 and 2, we have R proportional L upon A, or R equal to rho L upon A, or rho equal to R A upon L, where rho is a constant of proportionality and its value depends on the material of the wire. The constant rho is called the resistivity of the material of the wire. If L equal to 1 meter and A equal to 1 meter square, then rho equal to R. Thus the resistivity of the material of a wire is the resistance of a wire of length 1 meter and area of cross section equal to 1 meter square. The unit of rho is ohm meter.